kernel panic party is tonight at 7. Check out Villages. There's still a lot of lockpicking and good stuff over there. And also check out the science fair. We have all sorts of really interesting things, all the way from the stuff government doesn't want you to know about, birds, to like mowers that move around all by itself. So I'm going to introduce Owen. He is going to talk a little bit about reverse engineering. He's a contributor to the Solid project as well, which is very interesting and something I'm hopefully will cover is going to be covered a little bit in this talk as well. Yeah. Awesome.
Well, I did not contribute to Solid. I've been wanting to use Solid because, no, you're all good. So yeah, welcome. I'm Owen Parkins, and today we are just going to be talking about using Kubernetes for reverse engineering. My main goal with this presentation is to just provide some details into various ways you can set up Kubernetes, like how I try to use it, how I experimented, and sort of the successes and failures. I know it's been about a year and a half or so that I've been wanting to learn Kubernetes, and I've been trying to understand the basics, and it almost took a full year of this trial and error and a lot of research to get more comfortable with the technology. Part of the reason that I want to present this is because KernelCon's theme this year is about the scientific method-ish, and so I just want to present the failures and successes and how we're continuing with this. So who am I? I'm a lover of new technologies, which normally somehow I forget the pain of that, of being an early adopter of things. For example, you saw me working on my presentation as you walked in because I couldn't figure out my window manager over here. Currently, I'm focused on learning Kubernetes and then the Solid project. And so the Solid project is just a way that you're able to control your own data and have it still interact with web applications. And I'm very curious on how that can be integrated into a lot more of our workflows in our lives. I do work at a federal research lab, so going back to point number one, you got to feel sorry for my peers, and then also love participating in the CTF. So if you have any questions after this talk, you can come find me in the CTF room and try to distract me or something from playing on that. So what is the motivation for actually using Kubernetes for this virtual, or for vulnerability analysis and such? First off, a lot of these cool tools that we use, a lot of times the dependencies aren't very friendly, right? You have to use different versions of Java, you have to grab a bunch of different packages, and it can just get really, really annoying. One of the main motivators for me is I was working on a CTF and I needed to download Ghidra. Let's not question why I didn't have Ghidra already. But because of how I was messing with systems and being an early adopter and everything, it just did not work. Right, and so from there, I was sort of on this vendetta to say, how can we get a way that we can quickly get set up on a reverse engineering project? A lot of the other motivation is that a lot of devices are becoming less powerful. Now, if you compare it to Apollo rocket, they're going to always be more powerful. But a lot of times we're focusing on ARM processors, right? We're focusing on energy efficiency. We're focusing on making sure they're light enough. This laptop that I'm on right now has a Xeon, right? We're not really going to be seeing those anymore. And a lot of those processings, everything's going to be in the cloud, right? We're going to see a lot more software as a service and a lot of those kinds of models, not only because of these devices getting lighter, but for other reasons as well. In addition, I'm passionate about teaching, and so if I can lower the bar for people to get into CTFs, reverse engineering, etc., being able to just spin up a container on a server somewhere and have people access it, super awesome. Also, like when they mess it up or when I mess it up and I just want to delete it and get a brand new one, that's also really, really nice. And oftentimes when we're doing CTFs and such, right, we're modifying our environment, making things all work, and then there becomes that point where you just, nothing works anymore. One thing I want to talk about with this, too, is some of you guys may be saying, Owen, use VMs. Come on, dude. Just template them, call it a day, move on with your life. The reason that I didn't want to is, I wanted to learn Kubernetes. Maybe I'm shoehorning Kubernetes into this little box, and maybe it belongs there, maybe it doesn't. Also, maintenance. Anytime I'm, trying to maintain templates, it just sort of goes south. That's definitely a personal problem, but I'm sure there's other people who have experienced that as well. So what I want to talk about is the 4 different attempts that I've tried here and just mentioning technologies. A lot of times with Kubernetes, it's a very overloaded term, and so when you're trying to describe to people how you're doing this, what technologies you're using, it just takes a while to process. And again, I want to point back to the science of hacking, right? We're not just perfect, we're all humans. right? So let's talk about the mistakes and how we have learned from those and how we grow from them. So the first one is using Rancher OS. Rancher is a company that helps you provide tools and things for Kubernetes, and they had this container-based OS. Okay, remember who I am? Love new technologies, right? I'm like, container-based OS, that sounds cool. I'm going to go mess with that. Can't really mount storage on the nodes, and like as you're working through it, trying to figure it out, you figure out, oh, it's not supported anymore because it's this tiny little script in there in the documents that say, we're not working on this, sorry. So that sort of just went all up in flames, right? So I deleted it and was like, all right, container-based OS, I'm still hooked on this. Let's continue this pain. And so I found Flatcar Linux. Again, container-based OS, really, really cool. For those of you who don't know what container-based OSs are, essentially it allows for all the services that are normally running. You can think of DNS, DHCP, etc., and they're all running in containers. And what that provides you is not only level of complexity that's annoying, but also allows you to just be able to download a new container. Thank you. It allows you to download a new container and update it, right? So in theory, it's easier to upgrade because you just bring down a container, bring it up, and you call it a day. Flatcar at least allowed you to modify the base OS to be able to mount paths, right? Because that was one thing that I was running into. But I couldn't get all the parts together. That was definitely a personal issue. There's basically the learning curve of learning a container-based OS and trying to figure out what I wanted to do from the world I'm used to, trying to shoehorn it. And then also Kubernetes is just too steep. So I was like, all right, that also went up in flames. Let's go on to number 3. Going back to something a little bit more familiar, right? CentOS 7. For those of you who just cringe because like, why the hell is this guy who loves new technologies using CentOS? The reason for it is because of maintainability, right? I am here to learn more about Kubernetes. I don't need to be maintaining an OS, right? CentOS is going to update less. It's going to be only security updates. Don't need to deal with it. What I found out is don't use XFS because the default installer will set FS mode equal to 1 or 0 or whatever, and it needs to be the other one. So that's really annoying. I also try to use RKE, so that's Rancher Kubernetes Engine, and that's a little bit more difficult to set up for a newbie, and I was like, oh man, I just sort of rage deleted that one, which got me into attempt number 4 in our last attempt, right? So you can see this progression of growth, still trying to get to my motivations and reach my goals here. Okay, we're sticking with CentOS 7, blah, blah, blah. RKE2 is a thing. When you're searching for RKE, make sure you include the 2. Very important there. And we're actually able to get it, right? So we sort of went through all these different attempts to get it, and here is sort of a recap of it, since I'm flying through it here. And can see it's not as early adopter as I'd like it to be, right? We could be cool and working on container OSs and all these different features, but at least it works, right? But this is over about a year. Partly due to time constraints, but also because I'm just reading, trying to understand Kubernetes, right, and trying to grow. And for those who use Kubernetes, you know it can be a monster at first. Afterwards, you look at it and you go, that's easy. I know exactly what all the ingresses and services and how all these things link together. But it's quite a hurdle there. So what it looks like in the end is I have this little cluster running, right? Have a hypervisor. I got a high availability setup because, you know, HA is cool, I guess. And why not? And then I have 2 agents. So the servers on that side are just going to be running the normal Kubernetes services, and then you have the agents just running containers, right? They're nothing special. They can drop off the face of the earth. Now, the thing I did do, though, and I recommend, is the separate network. The separate network here is just because Kubernetes has a lot going on, right? There's a lot of interfaces. There's a lot of open ports. And if you want to mess with firewalls, that's fun and all. But I'd rather just throw it into a VLAN and move on with my life at the moment, right? I can go back and figure out the intricacies of which ports need to be communicating to what and such. And I also put a Bastion host there. And the reason I did that was so that nobody else can access it unless I give them permission, right? So it's sort of a normal setup, but it's something that, like, if you throw Kubernetes on a network and you're not really sure what it's doing, probably don't want to be doing that right away, right? So why does this matter? Who cares, right? Well, we were able to build, because it's using RKE, we have Rancher on there, we're able to build this catalog that has these tools in it. So here's a little zoomed in screenshot here. You can see that I have different primarily Android reverse engineering right now. But you can see that I have Android Studio as a little package. You have Cutter, MobSF, NFS storage, right? And the cool thing is that this isn't a GUI. Now, I love command line, right? I'm running Arch up here. I'm gonna have all my street creds, right? But for people joining, people just starting in RE, this is very approachable, right? This is very nice, and it allows them to dip their toe in the water and then become hooked. Now, when you want to actually go install things, you're able to just get a nice screen. You're like, hey, which version do you want? Hint, don't use any of the others. And it tells you sort of what the tools are, right? Now, I wrote that documentation, and it's really awful here. But you can see that it has Android Studio, and then for those in the back, it has Dex to jar, YSO serial, man-in-the-middle proxy, right? I started adding these useful tools that I'd come across and be like, hey, I really need these, right? And so when you press install, it's like, hey, here are the defaults, but if you need anything else, here's a description of the changes that you can make. Right, again, this is going towards that goal of, can you quickly spin it up? Can somebody who's brand new come on board? And in addition, something like this makes it that somebody comes to me and says, hey, I really want to try reverse engineering. All right, yeah, go to this URL. Here's an account. Click here, click here, click here, and bam. You have a Android Studio running, right? You don't care where it is. It's in a browser, so it doesn't matter what device they brought to the table. You're able to just sort of move on with your life. Now, how this is actually running is you have one container that is Android Studio itself, and then you have another container that's running no VNC. And so Android Studio is just running inside of a X11 frame buffer, so it's all in memory, and then that's just VNC'd out, and then no VNC supplies it to the browser. So that's really nice and easy. It also allows you to run another one, right? Okay, that's cool, but what if we're needing to switch tools? What if we need to operate on a file in a different container, right? All right, cool. Now, what this is showing, what this eye chart is for most of you up here, is that this is the same file system on both of them, right? Same file, same sizes, everything. And that's where that NFS layout comes in handy. So overall, with Kubernetes, it looks really complicated, but there's a fine division between the base system itself and the services provided. So the base system itself is going to have RKE, it's going to have Rancher for modifying it, you're going to have Longhorn for storage. Now, Longhorn isn't the only one for storage. There are other storage providers, and we'll get into why I chose Longhorn. MinIO is just a S3 bucket, basically. You're just able to throw in stuff and just use it. And Harbor, though, is really important. And the reason it is because you can rate limit yourself on Docker, or in my case, rate limit your entire federal research lab by them, because you are just pulling in too much because you don't know what Kubernetes is doing, right? Every time that you spin up a container and you don't have your flag set right, it's going to pull a new container. So Harbor is set up as a pull-through proxy, and that is really, really nice. On top of that, then that's where the things that I just showed you are. There you're going to have your NFS storage, you're going to have your MobSF running on the side, and then those other little containers. So what am I actually using in here? So I have Longhorn, and the reason for it is it's fairly easy to deploy. There are other providers. You have Ceph, you have things built in on Kubernetes. Kubernetes can use things that are built off of the platform. It's a little bit more opinionated. So again, I'm focused on, can I put reverse engineering tools inside Kubernetes? All right, I don't really care if my storage is doing all these fancy things. I just need storage, right? No VNC for the browser access, OpenBox for the window manager, because if you remember your Linux GUI stack, window managers are sort of important in that whole thing. But I wanted it to be lightweight, right? I don't want to be focusing on resources that need to be elsewhere. And then NFS. The thing about NFS, it feels very un-Kubernetes-like. I feel like Kubernetes should be providing my shared storage between all my containers and everything. And I know there's a solution, but I needed something that works, right? So this sort of leads into, is it usable? Yes, it is usable. I've used it. I have a few people using it, but there are a few changes that I'd like to make. So again, first, the changes right now is flat card Linux. I want to go back and suffer and learn it and understand it a little bit more. I think the maintainability of it will be nicer than CentOS in the long run. I also want to improve the styling because right now it doesn't look that great. Now, does that matter to people like you and I? Not really, right? But it can just be a nice lowering barrier, especially if you're teaching at colleges or high schools or other places like that. I also am worried about the workflows, right? Everyone here has a different workflow if you're in RE, what tools you're using, how you're using it, and even between when you started and where you're at now, you have a different workflow. So is this going to fit inside that workflow, or are you going to be trying to form are you trying to change the person to the machine or the machine to the person, right? So that's something to be researching. Also, ensure your containers are resource limited or else you bring down things. So hint with mobsf, if you go set it up, you will destroy a computer basically. You have to go change a setting and it will limit the memory usage and life will be good. So there is some future work with this though, after those little changes, because I want to keep collecting more applications. So if you have any applications that would be lovely to have in there, let me know. Any things that you think would be a beast to get running in there, I'd love to know it. You know, I chose Android Studio because I knew that was a monster, and if I could get Android Studio running in it, it's like I could probably get anything else running in it. Built-in documentation, because we all love documenting, right? Yeah, okay, that's what I thought. But having it around, that way beginners can join it. Also, the other thing I wanted to touch real quick is RK2 is about to release a version that will come out on ARM. So this is really, really cool because if you have an ARM server, which are becoming a little bit more prevalent, you can start creating ARM devices with an emulator, and you can hook it up to OpenSTF if you're familiar with that, or device farmer is what it used to be called. And you can sort of have a virtual device farm, which if somebody, which this sounds like Corellium, it basically is Corellium, but you're building it yourself. And so the usefulness of that is that people could develop Android applications, people can debug Android applications, they can reverse engineer them without an Android phone hanging around, or a x86 version running and stuff like that. So it allows you to do a lot more cool things. So really excited to be able to set that up. So with that, that is the quick presentation about Kubernetes and reverse engineering. If you have any questions, I'll be in the CTF room because I think I have 1 minute left. Right. Cool. So thank you.